All right, good morning, everybody. Happy Tuesday here. I hope that you guys are all doing well. I just want to kind of give you a little video about Pythagorean theorem. I know the Ed puzzle video for some reason was not very user-friendly yesterday, and the last question was making everybody restart. I'm sorry about that. So we're going to try and see what we can do here. By watching this, I'll give you a couple examples and kind of how-tos before you get into your Delta Math practice. So first, let's start off by looking at Pythagorean theorem, where Pythagorean theorem works for triangles. However, it doesn't work for triangles that look like this. And the reason being, it needs a 90-degree angle. So I'm just going to put an X through this one here. So it needs 90-degree angle. So that's the only time we're able to use our formula, which is, if we remember from yesterday, a squared plus b squared is equal to c squared. Now these ones here, a and b, those represent the legs of our triangle, and then our c value is your hypotenuse. Hypotenuse is always opposite your 90-degree angle, and it's always going to be your longest side. So let's get into a few problems here where we can practice. Let me draw another triangle here. This time, let's get it to be a right triangle. So if we were to give a triangle that looked like this, pretending as best we can, I know you guys will critique that there. We're going to say that this is our 90-degree angle. So if that's the case, we know this distance across from it is our c value. That has to be our hypotenuse. It has to be our longest side length. So our legs of our triangle would be A and B. And you can flip-flop that order. You can say, you know what, let's call this A and this B. It really makes no difference whatsoever. But let's give these guys a distance here. Let's say they look pretty close to the same. Let's call this 4. We'll call this one 5. So if we were looking for our distance of C, we use our formula. A squared plus B squared is equal to C squared. And we just substitute in. So we have 5 squared plus 4 squared is equal to C squared. So we got 5 times 5. It's not 5 times 2, it's 5 times 5. So we have 25. 4 times 4 is 16. We're going to add those together to get our value. And then once we add those there, we're not done. So that would be 41. So we're close. Okay, we have c squared. In order to get c all by itself, we use the square root. So we have the square root of 41 is equal to c. Right there, that's our best answer. Right? That's our best answer. We're not doing any rounding or anything whatsoever. However, if you take the square root of 41, you can reduce that and get a numerical value. And if you guys use your calculators, there's that square root function. It kind of looks like this. And we know that we're between the values of 6 and 7 because we're at 41. But it looks like this on your calculators there if you were to use the square root app. So the square root of 41 is going to be 6.4. So that way we are getting a better idea of what that distance is. So let's take a look here at another different triangle. I'll leave that one so that way we can use that as a resource. But let me see if I can draw another right triangle. Hopefully we can get a little bit better here. Let's do the opposite way or flip it. So let's see if we can get a good triangle drawn in. Let's do one. Hopefully that fixes it for me. I don't like that one. Let's redo that. Let's see if I can draw better. Got me more space. Thanks for being patient. Now let's do our triangle here. We'll work with that. There you go. Okay. So again, labeling our parts of our triangle. That's our 90-degree angle. So this side opposite needs to be your C value. This time, let's give the value for our hypotenuse. Let's say we know that distance. That distance is going to be, let's say, 12. And they want us to find one of the legs then. We have two parts, we're looking for the third, so we don't know A, but let's say we do know B. And now B, it has to be a value less than 12. You cannot have a right triangle if B is going to be larger than 12. So you have, let's make that one, I don't know, 10. So using our formula just like we did earlier on over there, we used a squared plus b squared is equal to c squared. We got to do the same thing for us here. Looking at this, I'll keep using blue. We got to label our parts. I'm just going to rewrite it all out. And now I can use my substitution. So if I don't know A, I'll leave A the same. I have our B value, which we know is 10. And then our C value we know is 12. And again, multiplying by itself, not times 2, it's multiplying by itself. So we got that as 100. And this is going to be 12 times 12, not 12 times 2. So this is going to be 144. And as we look at this, this is very close to what we just did in our last example. So this is going to be 44. And last example, we had a square root of 41. So we know that we're close. So if we look, I'm going to rewrite it over here. So this is a squared is equal to 44. We need the square roots of both. And again, we're falling in between that values there of 6 and 7. So we got A all by itself. This right here would be our best possible answer, but we want a numerical value that we can relate with. It's a little bit more than 6.4 because this is square root of 44. It will be, our distance for A is 6.6, and we got a couple of 3's, right? In this instance, this is an irrational number. It goes on forever. I'm just going to call it 6.6. We can round. That's all right with us. And that's making sense. We have that distance there. It's a little bit smaller, right? And so we wanted to make sure that we get a distance that makes sense to our triangles. All right, let's work this one more time. I'll do a little bit more relatable real world problem here. I'm going to take those two out. All right. And so using Pythagorean theorem, it's always the hypotenuse is C. And typically when we use something like this is once when we have maybe, let's say, a building, if it's standing upright, and we were to have that there, and let's say we have a person coming in to fix a broken window. So if our window is here, they need to get a ladder up to that distance there. So here's their ladder coming in, right? There it is. So we start to see how these are important for us. So if we know the distance of the ladder, let's say that this is a 14-foot ladder, we want to be able to position our ladder with enough space here so that way we get to that distance of our window. Okay, let's say that the window was, right, so it has to be less than 14. The distance from our window here to the ground is going to be, let's call it 8 feet. Okay, I'll use our measurements here. And so this is where we start to kind of use Pythagorean theorem out in the real world. And we don't know this distance. We can label it A, we can label it B, it makes no difference. I'm just going to call it A. So what we're going to use, this is our 90-degree angle because our building is standing straight up and down. We know that 14 is our hypotenuse. So we have our formula. Okay, hopefully you guys love my drawing. You probably missed those. I miss drawing them for you and getting the response back that you guys loved it, right? So we have our B value is 8 and our C value is 14. So we don't know A, that's what we're solving for. And we got 8 squared, which will be 64. And we got to do 14 times 14, not 14 times 2. So again, remembering our perfect square song, I might need to put that one back in, right? And that way you can sing along to your family at home. So we have that is 196. We're going to subtract with 64 to both sides, so that way we can isolate A. And when we subtract with 64 to the right side, that's a 132. So now, thinking about this one here, what two perfect squares are we between, right? So as we look at that, we can look and get the square root, right? So we got A all by itself. Now we're between 11 and 12, because the square root of, 11 squared is 121, and 12 squared is 144. And for us, we see that we're right in the middle, pretty close, and this is going to be almost identical to right in the middle, but we're a little bit closer to 11. So this is 11.489, which we can round if we want to. Let's just make this there. So this distance from the building to the ladder depth, we need to have that at 11.5 feet. Otherwise, we wouldn't be able to reach that window to fix it, to clean it, or whatever we needed to do. So that's where we can start to see some of these problems work out in the real world for us here. So hopefully you enjoyed this practice. I know this video ended up being a little bit longer, but go into Delta Math, try those problems out, see what you can do. You'll get instant feedback from the program, and then that way I'll be able to see where I can help you out for the next videos. All right, have a great day. Miss you guys.